Greetings, my name is Dylan, and today I will be giving a summary of the paper Cloud Computing Security, a Survey. The paper reviews major security and privacy concerns associated with cloud computing, as well as identifies cloud vulnerabilities, organizes securities into categories, examines common attacks, and evaluates proposed countermeasures. I will first explain the basic cloud models, then discuss the main security categories, major attacks, and the author's conclusions. Cloud computing delivers resources such as servers, storage, software, and processing power through the internet. The paper compares this model to utilities such as electricity or water. Instead of maintaining all resources locally, customers connect to a provider and uses the resources they need. Cloud computing is attractive because it is scalable, flexible, and can reduce hardware and maintenance costs. However, customers also give up some direct control over their systems and data, creating new security concerns. The paper identifies three service models. Software as a service provides complete applications over the internet. Platform as a service provides an environment for developing and deploying applications. And infrastructure as a service provides virtual machines, storage, and networking resources. The four deployment models are public, private, community, and hybrid clouds. These models differ in ownership, access, and control. The amount of security responsibility assigned to the provider and customer changes depending on the service and the deployment model. Cloud computing offers several benefits. Organizations can reduce infrastructure costs because they do not need to purchase and maintain all their own equipment. Resources can be added or removed quickly based on demand. Cloud services support remote access and allow providers to handle tasks such as maintenance and software updates. Cloud security is important because data and infrastructure are no longer fully controlled by the customer. Cloud platforms often use multi-tenancy, meaning several customers share the same physical resources. Although customers are supposed to remain isolated, technical flaws could allow data to leak between tenants. Cloud services also depend heavily on network connectivity. An outage or denial of service attack can prevent users from accessing important applications. Because cloud providers store large amounts of information, a single successful attack may affect many organizations. The author divides cloud security into 5 categories. Security standards include policies, auditing, compliance, and legal agreements. Network security covers communication systems, firewalls, and protocol vulnerabilities. Access control includes authentication, authorization, account hijacking, and insider threats. Cloud infrastructure includes APIs, virtualization, hypervisors, and multi-tenancy. Data security focuses on confidentiality, integrity, privacy, recovery, and availability. These categories provide an organized way to understand cloud threats. The first category involves standards, governance, and trust. Different cloud providers may follow different security practices, making it difficult for the customer to evaluate their protection. Organizations may also face compliance risks because they cannot always inspect the provider's systems or processes. Service-level agreements should clearly define availability, data protection, incident response, and responsibility after security failure. When these agreements are unclear, customers may not know what protection they are receiving and who's responsible for a loss. Cloud services depend heavily on networks, so firewall errors and weak configurations can expose systems to attackers. Protocol vulnerabilities and denial of service attacks may interrupt access to cloud applications. Access control is also critical. Attackers may steal passwords or authentication tokens through phishing and software vulnerabilities. The paper also emphasizes malicious insiders. Administrators may have a broad access to customer information, so misuse or privileged access can cause data theft, disruption, and reputational damage. Infrastructure security includes weaknesses in APIs, virtual machines, and hypervisors. Customers manage many cloud resources through APIs. An insecure API may allow unauthorized commands, stolen tokens, or account access. Misconfiguration is another major concern because one mistake may affect several services. Multi-tenancy also introduces risks if isolation between customers fail. Data security requires information to remain confidential, accurate, and available. Organizations must also consider data backup, recovery, privacy, and physical storage location. One of the paper's most important ideas is that cloud security issues are interconnected. For example, a lack of standards may contribute to weak authentication or account hijacking. Poor auditing may allow malicious insiders to act without being detected. An insecure API may lead to unauthorized access, and that access may result in data leakage. This means organizations cannot protect the cloud with only one tool. Security requires several layers, including policies, authentication, monitoring, encryption, auditing, and secure configuration. The survey identifies 9 major attack groups. Threat of service attacks allow users to consume resources without being properly billed. Denial of service attacks makes cloud services unavailable. Malware injection involves placing a malicious service instance into a cloud. Cross-VM side channel and secure shared memory attacks attempt to collect information from other virtual machines using the same hardware. The paper also discusses phishing, botnets, audio stenography, and virtual machine rollback attacks. These attacks may result in unauthorized access, stolen information, service disruption, or damage to infrastructure. The consequences of cloud attacks can be severe. Attackers may steal login credentials, access private files, or impersonate legitimate users. They may also modify, expose, or delete information. Denial of service attacks can interrupt business operations, while theft of service attacks create financial losses. A cloud breach can also damage an organization's reputation. Customers may lose trust if their information is exposed or services remain unavailable. The paper discusses several defenses. Intrusion detection systems monitor traffic logs, and user behavior. Firewalls and traffic filters can block suspicious activity. Strong authentication reduces account hijacking, while secure APIs help protect unauthorized commands. Encryption protects stored and transmitted data, and backups support recovery. However, these defenses have limitations. Monitoring may reduce performance, and some systems cannot scale to large cloud environments. Privacy can also restrict how much providers inspect customer data. In addition, several proposed solutions have not been fully tested in real environments. Cloud computing provides flexibility, scalability, and cost savings, but it also introduces major security and privacy challenges. Threats can affect cloud networks, user accounts, APIs, virtual machines, policies, and stored data. The paper shows that these problems are connected, meaning a weakness in one area can create risk in another. No single tool can completely secure a cloud environment. Effective protection requires technical defenses, strong policies, clear agreements, auditing, trust between consumers and providers. Overall, this survey provides a useful framework for understanding cloud security and identifying areas that still require improvement. All information in this presentation is referenced from the paper Cloud Computing, Security, a Survey. Thank you for listening.